In earlier video, we discussed about the extraction of lanthanide ions by using tributyl phosphate as a solvent. In this video, we are going to discuss the extraction of lanthanide ions by using bis 2-ethyl hexyl phosphoric acid, and at the end of video we discuss about the applications of lanthanides. Now this solvent, that is bis 2-ethyl hexyl phosphoric acid, it is more efficient as compared to tributyl phosphate, and it has an average separation factor of 2.5. and you know that when separation factor alpha it is exactly equal to 1, then separation is very difficult, and when separation factor deviates from 1, if it is less than 1 or greater than 1, then separation will be easier. For tributyl phosphate, separation factor is approximately equal to 1.5, and even that it is efficient, no doubt, tributyl phosphate, but as compared to tributyl phosphate, bis 2-ethyl hexyl phosphoric acid has a separation factor of 2.5, and therefore it is more efficient. Now at the time of extraction of lanthanide ions by using this solvent, the aqueous solution of lanthanide ion, it is shaken with the sufficient quantity of solvent, that is bis 2-ethyl hexyl phosphoric acid. Now during the course of extraction, the lanthanide ions form the complex with this solvent, and there is a formation of less polar complex of lanthanide ions with this solvent, and automatically there is a formation of two phases, aqueous phase and the solvent phase. In solvent phase or in complex ion phase, the lanthanide ions are automatically extracted, and that phase, solvent phase, it is separated by means of by using separating funnel, and just solvent is evaporated or removed by simple method, and we get pure lanthanides. And the equilibrium involved during the extraction of lanthanide ions with this bis 2-ethyl hexyl phosphoric acid is, so aqueous solution of lanthanide ions when mixed with solvent, there is a formation of solvent complex, which is in organic phase, plus 3H plus, and the equilibrium constant for this chemical reaction is the equilibrium constant K, it is equal to concentration of lanthanum complex, this one, into concentration of H plus cube upon concentration of Ln3 plus aqueous into concentration of this solvent, organic solvent. Similarly, distribution ratio, that is lambda, it is equal to K, that is stability constant or equilibrium constant, into concentration of solvent upon concentration of H plus. So in this way, bis 2-ethyl hexyl phosphoric acid, it is one of the efficient solvent for the extraction of lanthanide ions from the mixture. Now, what are the applications of lanthanides? So lanthanides and their compounds have wide range of applications in various fields. Now some of the applications we are discussing here. So first of all, commercial applications. One of the important metal alloy of lanthanides is mixed metal alloy, has a composition of cerium 45 to 50%, lanthanum 22 to 25%, neodymium 18%, praseodymium 5%, samarium 1%, and it is used as a good scavenger for oxygen and sulfur. Now along with magnesium and zirconium alloy, This mixed metal alloy, it is used in making jet engines. Even when this mixed metal it is alloyed with 30% iron, then it can be used as a lighter flints. Lanthanum or lanthanide iron cobalt alloys are used in making permanent magnets. Cerium oxide, it is used for polishing optical glasses. Lanthanum oxide, it is used in making camera lenses, motion picture projectors, etc. Then cerium salts, various cerium salts are used in dyeing of cotton. It is very good reagent in qualitative analysis. Then mixed lanthanides along with zeolite, it is one of the good catalyst for cracking of petroleum. What are the nuclear applications? Now some lanthanides are used as moderators and neutron absorbers in atomic reactors to control the rate of fission reaction. Here gadolinium, samarium, europium, dysprosium, these are used as a moderators and neutron absorbers in atomic reactors to control the rate of fission. Now at the time of controlling rate of fission, the long rods made up of these materials or elements are introduced into the core reactor. Okay, and during the course of this nuclear reaction, these rods are inserted in the reactor. Then as soon as nuclear fuel is added, if some rods are taken out, the fission reaction begins. With the removal of more rods, the fission reaction rate, it will accelerate, it will increase. And if all the control rods are introduced in the reactor, then fission reaction will stop. So in this way, the nuclear fission, it is controlled by using these moderators or neutron absorbers. And the order of nuclear cross section, it is gadolinium, samarium, europium and dysprosium. So gadolinium has highest nuclear cross section, whereas dysprosium is having least nuclear cross section. Similarly, lanthanides are also used in atomic batteries as a source of gamma rays for the dilution of fuels, etc. Now, number of lanthanide isotopes have desirable properties for special applications. They have some potential use in making X-rays also, gamma rays and X-rays, as radioactive materials for the treatment of cancer, and also tracer studies. Some lanthanides are used in the treatment of cancer also, as well as in tracer studies. The lanthanides are used as a diluents for nuclear fuel. Now third important application is magnetic, electronic and laser applications. Samarium and cobalt, neodymium, iron and boron, these alloys are used in making permanent magnets. Lanthanides are also used in a variety of current technologies, including screens and electronics of smartphones, batteries of electric cars, satellites, and lasers. And applications of lanthanides as a catalyst and some other applications, especially cerium phosphate. It is used in petroleum cracking as a catalyst. Lanthanide oxides are used as a catalyst in hydrogenation, dehydrogenation, oxidation reaction, etc. And cerium phosphate, it is a good analytical oxidizing agent. So in this way, lanthanides finds very good applications in some of the fields, including nuclear field, magnetic area, electronic area, in the making of lasers, as a catalyst, as a reagent, etc. Now here we completed the chemistry of inner transition elements.